that you have. So that this can be done after as well. We have a ton of questions coming from other sessions before. It's been really fun to understand the usage of Scrum in a more particular thing for the space environment. So that's where I would say that the value is this association between these two components, space and the Scrum Master methodology from Joe. Then in here, today we are dedicated to what's called Space Architecture. I have a video of mine that essentially walks you through what's the SMAD, the Space Mission Analysis and Design. It's a very well-known book in the arena of space. And if you click the link, it will open up the SMAD. And yeah, there are versions out there. This was James R. Words. I think there is a new edition. This has been there forever, you know. The brutal thing is the overall amount of links, the amount of information. These are just the tables. Things like how to create a delta V budget. Delta V budget is how you transfer from one orbit to another, and you hit download, and then suddenly I'll show you because it opened on the other side. Come on. Like this. Please move this window away from the share that. Okay. I don't know why. Okay. So you have ability to calculate this and this. So it's really, really well, pretty cool. So I think you see why. Oh, it's sharing again. Very, very interesting. Let me see if I can share. Can I enable editing of these? It's straightforward to share, I think. Oh, please. I'm very curious. So there's some kind of. Well, nevertheless, this is not mine. The full references and credits to the authors. You guys can come in here. The one that I've used in my video was this one, the Mission Operation Cost Prediction Model. There is a whole array of things. Very, very interesting to use in terms of idea. The example on in here, it's called the Firestat 2. It's just really, really cool, to be fair. Really, really cool. Now, if we go down, in here, we also have links and downloads. See what happens when you open a link. Okay, cool. At least the links work as, that's so nice. All the images that you've got in the chapter. So that's really, really, really interesting to see. Orbital performance, role of standards. Well, many folks don't like to talk about standards. Simple missions. This is also very interesting because simple missions is part of when you do a concept design. Understand how does a simple mission relates to yours. So that's an interesting one. This one, the complex tool sets of engineering. Lots of things have changed in the past. This was 2011, so don't pick it up as much. But okay, so got the idea. Overall, methodology-wise, what is fun in here is that for the overall space mission life cycle, mission concept, it has a set of, I'm going to call it important and relevant elements. Okay, space mission architecture. So this is this figure again from the same book. All space missions include these basic elements to some degree, some text. See text for definitions. I can give you essentially the examples because we are doing this for the moon rover, and in fact, we will see that for the moon rover, some of the things don't apply exactly like it is, but the thought process is the same. So that's what I wanted to leverage today. And I want also later on for us to see the Blue Origin. Well, Blue Origin did something, their things, a great thing for us here. It's the whole idea. I think everyone knows. Well, at least that's the point. That it didn't work, but it worked.
9.
So it did. Go in here to the post-launch. T+1, so all good with there. I hope it had some sound, but it doesn't. Oh, you can hear the sound. Nothing at this time. The exact. Let's go and see what happened, because there was an anomaly exactly.
That's the point where the aerodynamic stress on the vehicle is at its maximum. We're going to throttle back and then continue on up to space.
You see, something happened, correct? Something with the booster, second stage, first stage, something happened. But the very interesting thing is that the capsule has blasted away, all emergency systems starting to work on, and it later on lands. Okay, it would have been a bump, okay, a really big bump, but that's not the case. So good job, fantastic job in there, because that's how you, if you think about SpaceX, it did the same thing in order to qualify for human space flight. Now let's go to Joe. The whole idea is that as we read, and then the exercise that we have to do is to pick up the moon rover. Or let me just get back one step. What you see in here is everything in here is working. The mission concept does not usually look into, okay, looks into the launch element, the ground element, the mission operations, who does that and where, command and control architectures overall. What you've seen is, what if one of these things go wrong, or several of them, or the interaction of them? That's what the engineers do when they deploy process FMAs, failure mode and effects analysis, or just known as failure modes and defect analysis. You'll see them as called FMA, but something went wrong around here. Something went wrong in the launch element, not in the payload. Something went wrong apparently in here. It could have been derived from many other things, but something went wrong in there. So whenever you build the architecture, it's important to build also, oh, what if it goes wrong? But now let's go back to Joe Justice, and open up, because this is a short one. And I think it's very, very, I'm going to call it profitable in terms of giving you value and what are the things.
Chapter 4, Jets. The F-35 is advertised as the most complex, most competent, most advanced multi-role joint strike fighter ever produced. At a purchase price of $180 million US per airplane, plus maintenance, the total program cost is calculated to be 1.5 trillion US dollars, making it more expensive than constructing all the Egyptian pyramids in adjusted currency. In fact, that makes it the single most expensive project ever undertaken by humans on Earth.
I'm going to put myself in here so that checking in with the information later on as we move in there. So I move usually to 1.2, 1.3 so that we can cover everything, which works well. But let's see some of the considerations here, because some of them are really cool to know.
The World Health Organization says 1.5 trillion United States dollars is enough money to feed every person on the planet for 50 years continuously and end world hunger. What happens when businesses and organizations and governments develop an attack or a defense that prevents the F-35 from completing its missions? All that $1.5 trillion sits idle until the F-35 program can deploy a countermeasure. In the world of global defense, these moves are attempted all the time, every week, continuously. How fast do the world's militaries want to design, develop, test, and deploy new countermeasures? Really, really fast. $1.5 trillion worth of fast. We don't get to talk about most of our work with the F-22 and F-35 programs, but we can show you pictures with signed releases taken from in Joe Justice's house. Here we see the head engineers from Boeing and Lockheed Martin for the F-22, the retired 3-star Air Force General, Ken Merchant, who helped the F-22 project at the time and now heads the F-35. A leadership team member for the F-35, the US government procurement officials responsible for purchasing the F-22, and the government organization responsible for auditing the purchase process to verify it is in the taxpayer's best interest. When we talk about full stack teams that can responsibly make decisions inside the team without waiting on external approvals, this is what we mean. This, by the way, is why an agile transformation is a leadership activity. It involves the policymakers of the company to sign a new policy and fund it. Now, you can do agile without a leadership team. You then have a voting mechanism, share-based or percentage-based, or everyone has an equal vote. And
okay, I want to stop here because this is very important. An agile transformation, or even any kind of transformation, starts from the top. As you'll see later on, Joe has been involved in other things, but in my experience as well, don't do transformations without getting involvement from the top, and don't lose it the moment you have it. Okay, it's really, really important. I've been in a couple of them, and when you lose that, you are in, I would say, deep trouble. Mostly, I would say gaining it's easier. Trying to gain after losing, it's way more hard. It's possible, but it's way more hard. And there are a couple of strategies to do that we can talk about, but let's go into the world of...
In the case of co-founders of a startup, that's normal. And everyone then votes. So the leadership function has to endorse an agile transformation. In the case of a company that's not flat, like the US Air Force or Boeing or Lockheed Martin, the leadership team has to endorse it to create a full stack team. When these professionals run the build exercise, they don't need to fold paper airplanes. They are so good, they can use metal and carbon fiber. In the pictures below, you can see these teams with a car they built in a similar amount of time to what most companies use conducting the airplane game.
Something happened there.
That car was phenomenal. You can also see awards and challenge coins from Boeing Commercial and Military, Raytheon, Lockheed Martin Space Systems, and Lockheed Martin Complex Systems, the F-22 and F-35. Most of this work we cannot discuss in detail, but here we can share that whatever work we may have done together was appreciated enough that we were honored with awards at award banquets and award ceremonies. Raytheon publicly announced their agility and radar systems in their investment portal to attract new investment due to their modern and fast-moving agile practices. So that at least can be shared. I've turned off my background to show you an award shelf. I actually took these out of storage to film this. I used to have them in my classroom, but right now I'm primarily online, so I sold the classroom. These were in storage. I took them out. So here is a model F-22 that was sent by Ken Merchant, retired 3-star general who now leads the F-35 program, with a beautiful note from Ken saying he endorsed me. You can see Ken wrote an endorsement for me on LinkedIn. Here is a Nürburgring Nordschleife plaque from me being co-captain of the race team at the Nürburgring. Here is a 3D printed Toyota Way from the early agile manufacturing operations in Toyota, from when I was working with financial services at Toyota North America, and the stamp and die system for the 2019 Camry and its aluminum roof. Here is an award from Boeing. Boeing Build Something Faster. That came from my collaboration with Boeing Military and the new model aircraft for Boeing. Here is one of the first test bucks, we call it, for the Wikispeed SGT-01. It's been battered and beaten. Maybe you can even see the paint's cracked. That's what the first car, actually it became the second car, looked like. This was a miniature model of the same CAD that we then made full size a day later. Here is a pin from the North American International Auto Show, the largest.
See, so there's an important thing in here. With the leadership, with the folks in there, you go and you design the CAD, and then you are able to design and build the thing. So that's the full end-to-end. And that's really important because these days we are a bit devised of this thing, the thing that happened. So I'm meandering myself into the world of, I'll show you something very interesting. Grab CAD. It's a fabulous location on everything. If you search for things like if we search for things like there are many outstanding and and fabulous ways to pick up. But if we just write racer, okay, you will find one of them has a competition, but this is the bucket drum. Many of the intents that was, oh, curiously, there is an advanced regolith design. See, it has the bucket, it has the drums in there, the blade bucket, it has a cover. What using motor for? Oh, so this should be, is this for a single person only, or? Yeah, it looks like, yeah, the regolith will not get stuck in there. So that's, you know, that's just a brilliant place to look into. There are more in there. There are many. It's a bidirectional. Oh, I haven't seen this one. By Roland Sandor. There are some of them that are phenomenal. Okay, some of them are really phenomenal. And yeah, let's see the one that is most popular in the Razor. Of course. Oh, it's of course, it's ours. Wow. We have 2 comments in there, so seems lightweight. Yeah, lightweight and very durable. So very, very cool. Correct. You see the I can show the 3D. We have to load the 3D viewer. I want to show something very, very cool. Let it open. So again, this is because we go into the CAD and then we are able to build it. Come on. It will get there. It will get there. So let me go back to Joe before we move inside the bucket ladder. There we go.
Just auto show at the World that time were exhibited on the main floor. An award from Big M and the Society of Manufacturing Engineers for keynote there. An award from Carnegie Mellon for guest lecturing there. An award from Jazoon, the Java conference in Zurich. An award from John Deere for my involvement in the S-Series Combine. Pens from Rockwell Collins, which has now become Rockwell Aerospace. Gold and silver coins from Lockheed Martin Complex Systems and Lockheed Martin Space Systems. Royal Bank of Canada, 3M, the Aspen Institute, the F-22, and Raytheon. Just to show that this stuff is real. Yes, I'm proud of it. I am proud of it, and this is a chance to share it. But I'd say also it's to validate and provide evidence that, yes, this work has been done. Yes, Agile is happening in these companies. Please use this as evidence of Agile transformations in large projects in case you need it. Agility is not only modern, it also has a long history.
Okay, so this works, okay? That's the intent coming from. This really works. You got more evidence that other things also work. I would say this works really well. We have an evidence because I've seen evidence with obviously with Lean and Toyota manufacturing systems and with business process managers some, but this one is extremely, extremely interesting, okay? That's why we are here.
Agile aviation, where high quality and speed of design productivity go hand in hand, is not new. When it's been needed, engineers and designers have operated at incredible speed. For example, in 1940, the P-51 Mustang, argued to be one of the very most effective planes of the era, was designed and the first prototype built in 102 days by North American Aviation. The inspect and adapt cycle is at least as old as 1620, with the articulation of the scientific method by Francis Bacon. Some people will say, Sir Francis Bacon. I try to avoid monetary and oligarchy awarded titles. I don't mean to be weird. I would love. In the 1930s, physicist Walter Shewhart of Bell Labs began applying Plan, Do, Study, Act, PDSA cycles to improve the design and provision of products and processes. In Saab Aeronautics, the 353 of Scrum has been used since at least 2007. Here is the executive and head of the structures group for another multi-role joint strike fighter, the Saab Gripen. They're wearing the blue jacket here as we're outside and it was chilly. There was light snow actually at the time. Jürgen Fulhelm, with Joe Justice in the middle, and the author of the book Scrum for Hardware, Paulo Samakeli. Joe and Paulo were allowed to write about what they learned there. Joe published a research paper, Owning the Sky with Agile, and recording an interview with Jürgen Wilhelm, both of which are available online. And Paulo Samakelli recording the learnings and analysis and this truly is a landmark book, Scrum for Hardware. And you can see the book here. There's even a free preview on LeanPub. That book is phenomenal, and it's now in version 2 as of this recording. I hope it goes even to version 10, but as of this moment, it's in version 2. Scrum for Hardware by Paulo Samakelli. Paulo is a genius. I hope more people, he's very well understood, very well read, very popular. I hope even more people find Paulo's work. The Gripen is built in iterations with cross-functional Scrum teams owning modules of the aircraft. They report Gripen teams have been implementing Scrum from at least 2007, iterating from the Gripen A variant to the B, C, D, E, F, and now even M and autonomous, unpersoned. They accomplish this by having 8 full-time pilots on site, working with all teams as needed during the 3-week sprints. While Paulo and Joe were on site, the teams were incorporating a new jet engine. This one was purchased from a supplier, and they accomplished the entire integration within the 3-week sprint. This was accomplished by designing a wrapper, an interface that adapted the inputs and outputs and mount points of the purchased jet engine to the inputs and outputs in standardized locations within the fuselage of the Gripen, the Saab Gripen. Jürgen Wilhelm explained, the architecture of the plane is like interlocking toy building blocks. They can be pulled apart and new blocks attached to the same mounting points very quickly. Please see Chapter 10, XM, Extreme Manufacturing, for more detail on modular architecture for speed in agile companies.
It seems so simple, correct? If these guys at Saab are doing it, why are we taking so much time to put Artemis up there? Why? Did something happen in there in the connectors? Did something happening in the helium tanks? Did something must have been forgotten? But one thing is clear in here: it's the ability to do and pick up. You guys will have it in here if you want to look into that. I would definitely emphasize that when we do this, where is we have in here from the other time our functional, the moon rover, here we have it. Okay, so we have the mobility system, the electrical power, the thermal regulation, navigation, extraction subsystem, and then all the other things. But all of these things need to be connected. Okay, so there are interfaces that connect the wheels to the motor, well, don't connect the wheels to the motor, but that's the interfaces between the electrical power and the transmission and the motor. All things that are connected should have standardized interfaces so that you don't worry about that. You should worry with what is the components inside of these, what are the inputs and the outputs. And for that sense, that's why we have the functions traversed back and forth from these endpoints. So doing things with the things, the way that they connect are these interfaces that Joe speaks about in here. Let's go ahead.
Reconfigurable means we can add applications without having to requalify the platform. We can even change hardware without affecting the overall application layer. Johan Sagertoft, project manager avionics platform for the Saab Gripen, Linköping, Sweden. We don't know what the fight will look like in 30 or 40 years from now. To ensure that we have a fighter that is still relevant, we are building it so we can easily upgrade it and use the latest and best technology out there when it comes to hardware and algorithms. Marcus Want, test pilot, Saab Gripen, Linköping, Sweden. The pilots fly the aircraft at sprint review at the end of each sprint. The dramatic enabler for Saab was negotiating with their certification authority to not require recertification of the aircraft when they make software and some types of hardware changes. This cannot be stressed enough. A long-running certification process, in some cases years, limits each sprint length to a minimum of several years. No product can be released to market, the purpose of a sprint review, unless it meets the tests and certifications required for use. Working directly with the testing organization, in this case, the certification organization for aircraft, the Gripen teams achieved an agreement to maintain the existing certification and not wait through the lengthy previously required certification process. How and why was this responsible? Saab Aeronautics and Saab Defense agreed to run every certification test themselves every 3-week sprint internally. Most of these tests are run virtually and continuously through simulation software. Saab invites the certifying officials on site each sprint during sprint review to verify the aircraft is still compliant. This enabled continuous certification and 3-week sprint rollout of an enhanced aircraft. Again,
I'm gonna stop this. So there are a couple of details in here that need to be really like focused and looking into it. One, the fact that they have the test pilots on site to fly it every three times. Okay, so that's really important. The second one is this agreement that they've made with the regulatory authorities or the compliance authorities, and they can think the same way if you are working in a system that requires, I don't know, imagine if you are doing products for consumers and you need to recertify the product, or if you are taking water samples because you sell water, guys, bring them in, bring those folks in because they would like to be treated. You put online data and it's straightforward. You reduce the time of inspection, you increase the velocity of the speed of the feedback. It's really different. In case of the FAA, the Federal Aviation Agency, same thing. They are humans and they want the flights to be safe for the ones they protect, the ones that are in the range. So big lesson from Joe in here. The understanding that if in any case, in any of my systems, or for example, in the moon, we do need to think about this, but there aren't many things. There is the outer space treatment up there, and you can use outer space treatment. Guys, it's a brutal piece of knowledge. Okay, it's obviously signed by the US, but it has many problems on how to deal with that. So that is something that influences the way that you utilize the moon. There are some folks out there that say that we can utilize the moon as we should, but there is still a treaty that 140 countries signed, I believe. So, okay, well, just me putting here what is key. We haven't talked about this enough, but fundamentally, regulatory resources are really important to manage. So they influence the way that we design a system. In this case, they influence command and control, mission operations, where you're going to lie, and what are you going to do with your mission? Well, essentially, it will obviously the subject of the mission. Okay, so anything that has to do what am I doing and where, really important to get those regulatory and coming in as early as possible so that they can influence the design of the system.
Again, for those who would like to learn more, please see Paolo and Joe's publication specific to the Griffin noted in the bibliography. Also, Paolo's book, Scrum for Hardware, talks about more.
And I've got these ready for you guys. So the Scrum book is over here. Not that one. Not that one. The Scrum book for hardware, okay? So Paolo Michele. It's also available in 18 figures and go to the project, of course. So $14, of course we can do that. I like 60 days of happiness guaranteed. Okay, so I'm not going to show you my credit card, so we'll continue in here. But you see what it is, correct? Let's go.
Every test that was required for certification was run in simulation constantly on whatever the most recent CAD and code that was checked in. So there is a full simulated aircraft flying through in simulation, all required aviation tests. And that simulation is running in emulation, the actual code that's checked in. By never stopping that program, and there are teams constantly updating it to have higher correlation with reality, and by flying the current planes every 3 weeks or more often to check correlation and make sure the simulation is updated, the simulation was so good, the certifying officials could just use the simulation and do spot reviews. Also, because they're approving the aircraft, well, saying it's still approved every 3 weeks, the changes are not multiple years long, they're 3 weeks worth of changes. So it's easier for the auditors to comprehend the total scope of change and make a responsible continuance of certification. We should make a strong point about cost. Not only did Saab prove that they could build an aircraft with Scrum, but it is also in some dimensions the best in the world. Jane's Aviation Weekly reports the Saab Gripen is the world's most cost-effective military aircraft, saying it is not only possible to design, build, test, and deploy an enormously complex system in 3-week sprints with Scrum, but when it happens, the product can be the most cost-efficient on the planet. The leadership structure to enable this is an executive team that continuously renegotiates the purchasing contracts for these airplanes with the world's militaries as their customers. The contract is then broken down into work to do, product backlog, by the teams themselves, using sticky notes on the walls. I'd like to clarify this. The executive team, my understanding when I was there, was not dictating to teams what they need to do. The executive team was essentially sales, negotiating sales to the Brazilian Air Force, the Swedish Air Force, and others. Then they have signed contracts, and the contracts are updated continuously. The development teams themselves would identify the modules and create backlog from the contract. They would write their own backlog. And then they would provide trend lines to when it was likely to be done. And then leadership's job is to update the contracts to reflect the reality of how fast the teams are actually responsibly delivering, which is inverse to a lot of top-down companies, especially you'd think in aviation. The teams then use their velocity, the average completed and tested work across the last 3 sprints, to report back to the executive team the date toward which they are trending to meet the key chunks of the contract. The teams themselves create the detailed plan and set the completion dates, and it is up to the executive team to maintain a signed contract that matches reality. As reverse as this may sound, this method is part of why companies with Scrum teams of top executives behave very differently, and some have tremendously stronger financial results. And again, this is part of why an executive-led Agile transformation is required, as the entire organization is trained to perform as Scrum Masters. It's not only military aircraft, however.
Done, isn't it? Lots of proof in a very directed way, starting from the top, involving several members of the team. No, the whole organization can work as Scrum Master. So why can't we do this more times? At least make sure these examples come alive. I'm sure there are things that don't go well. And there is a chapter in the book that talks about that, but let's go ahead.
Mitsubishi's regional jet, called the Space Jet, planned to have dramatically larger interior volume than its predecessor and named the Space Jet to boldly state its large interior, has run into budget overruns and near cancellations many times over. In fact, it was canceled at least once now. In the public press, this aircraft project is understood to be high risk, having difficulty getting anything done. An acquisition of Bombardier brought in some Scrum Masters to Mitsubishi, who began working in Scrum teams even without senior leadership approval or awareness. And their work began completing on time, even early. Mid-level executives requested Scrum training and requested additional teams be trained. The goal for Mitsubishi is now to save their regional jet project, even if it means restructuring the organization to work in sprints of completed modules of products. The previous waterfall plan had separated the work into phases and handoffs. In the previous plan, one organization would create the plan of the jet, and a separate internal organization would build according to the plan. Many of the executives recognized during their Agile training the risk of regression in the previous non-Agile plan. Regression occurs when a plan is handed off to another group to analyze the plan, then handed off to the second different group to build according to the analyzed plan, and handed off to a third different group to test and build the product.
Have we seen this?
And finally handed off to another organization to deploy and support the tested product. What occurs is that problems found in testing, or when the product is deployed and being supported, require updates to part of the planning phase and starting the process again. This had occurred too many times within Mitsubishi, making the planning stage never sign off as complete, and they were running out of money. The solution? Don't end the planning stage. Stop trying to get the plan perfect without feedback from actually building and flying with customer collaboration. Instead, the Scrum Masters in the organization are proposing each sprint plans, analyzes, builds, tests, and deploys a module of the aircraft. For example, in the Agile plan, the fuel tank is...
This is really the thing. When we see plan, do, check, and act, in here, it's not, we've seen it like this one leads to this one, yes, but it restarts again in the next time frame. So we are missing the dynamic of it. See what I mean? So you take a snapshot, it's plan, do, check, and act, and it's always happening. Well, probably in the first one, you just plan and you start immediately going, but the next instance, everything starts happening again and again. And this is a very interesting way to pull up that.
Proposed to be tested on the ground and in the air in sprint on a modular test plane with stable mounting points. The stable mounting points are proposed to last into the production aircraft, allowing fast maintenance and future upgrades. In this way, the plane may be re-architected to be similar in modularity to the Saab Gripen. Boeing has also trained all the executives leading their next major commercial aircraft. This Scrum training has empowered them to choose how best to set up this massive program from the onset. That's the NMA, the Boeing New Model Aircraft. Airbus has executives have built cars with Joe Justice in order to learn Scrum in hardware sprints. Airbus continues to post job openings for Scrum Masters. In aviation, commercial and military, we are seeing the market benefit. Desire for faster time to market of improvements and new capability drives Scrum Master training for executive leadership, group leaders, engineers, new hires, and even interns. The takeaway of this section, if you're teaching this course or taking this course, is this Agile stuff, these short iterations, works even in the most complex systems humans know about, with hardware, software, vendors, government contracts, approvals, regulatory. Now, a sprint still means done and on sale. So we wouldn't have a planning sprint and a build sprint and a test sprint and a certification sprint. The sprint length must include all of those. So for all these companies, the first sprint is super long. It's years long because it's to go from design, at least an updated design, at least an update of a current design, through build, test, and deploy. A sprint is a complete waterfall, including certification. Now we use technical practices to shorten that waterfall, to shorten that sprint and try to get it to less than a month. And the reason we want to do that is because of the Standish Group's data showing small projects of less than a month are enormously more successful than large projects. We'll see that data later. It's like 64% less likely to be a complete and total failure. We'll see the actual numbers soon. So the takeaway here is you can really do this. You can do this in software, you can do it in hardware, you can do it with procurement, with vendors. And the enabler is whoever makes structure of the company decisions needs to be on your Scrum team, so they can make incremental structure of the company decisions. Without that, we can sub-optimize. So let's say you're a CIO, Chief Intelligence Officer, or a CTO, Chief Information Officer, or Chief Technology Officer. You could speed up the hardware in your company because you can restructure that group, but you wouldn't be able to directly affect the hardware until the executives in charge of that, if you're in a traditional hierarchical company and still have executives, they would need to architect their transformation. In Saab, the leadership group runs as a Scrum team to get signed contracts. That enables the entire company to feel that rhythm. And they do a 3-week rhythm. When you get super fast, you don't actually need a rhythm. You can transcend a rhythm. But we'll talk about the benefits of a rhythm in a later chapter. Okay, that was chapter 4.
Okay. So this was chapter 4. It's way more fast than all of the others. It provides many interesting lessons in here, but I do. So if as you walk to the homework, let's go in here. So some of the questions that are obvious are these. Okay. How do we start at the top? If, for example, this is very hierarchical and we don't want to get messed up or don't want to, how do we do this without that first initial bump of trust? Okay, so that's one. Okay, that's one that I think we need to work on. Okay. The second one is getting all the, I'm going to call it functional architecture together, all the functional, and this is design, test, build, sell, get feedback. Although feedback can happen anytime, but that's the feedback from the customer. How do you do all of that in a single sprint for complex things? It does seem to be possible. Well, it's obviously possible because the example that we are working on, that I'll show you next, the feedback is there as well. I'm going to say the third thing that got to my mind is how does it change if we have, as if, for example, we have change for is there a degree of formality that we need to have? It will be my 3 questions. So getting back to our, I hope it has loaded so that you guys can see our CAD. Come on. Is it a yes? Is it a perhaps? Is it the who knows? Yeah, is it the who knows? Let me go back to that. So again, grab CAD. We have a fabulous library of things in here. I'm going to share this again because this was a. Let's hope. Oh, okay. Some concepts in here. Let me get back to the GrabCAD library. You can see. So let's go to GrabCAD. It's very, very interesting spot to be on. Go to the library and just write freezer. And as we sort out by most popular, guess what? And then March, this was 2020. So many folk download our thing. Looks good, doesn't it? So the skeleton view of the two extracts is shown. Got the bucket drums excavated by twisted spring scoops, compiling materials inward into a bucket cover. This capable of filling. Ours is slightly different. I cannot show you the design yet, but it's slightly different from what we have in here. But it still uses, of course, the same principle because this architecture is really, really good. I can show you, well, there is a nice NASA research paper that explains why this architecture is good. So getting back to the homework. So I got the book done regarding spacecraft architecture. Let's say pick up the SMAD. The example that I gave was on the Blue Origin side, something that was built to work well. This is the overall space mission life cycle. It starts from here as you elaborate the mission and design life cycle. And then in here, you've got all the things that influence the mission architecture. Okay, there is one very interesting one in here that it's the following, that in here sometimes payload space element, this space element over here, it's kind of, we do need, so something that launches, something that is in space, and all the orbital constellations, what's the subject of the work, how do you command and control, what are all the towers and communication circuits and all of that. So this will definitely influence the mission design. What I mean, the mission is also the thing that we are doing as well. And let me share this. Let me share something that I found that was really, really good. That I wanted to bring in today. Not the mission, not the that has to do with the, I would say, the types of things that we find on the moon, the types of problems that will influence the design. And that's really important because all of these things are like building up requirements, building up things that you need to satisfy if we're going to go to the moon as you design your project for the moon using this methodology. Okay, there are others, but this one is probably the first step to do things. Here we are, pulling up the file. What really makes everyone think is, in the case, we know what's the ground element, think for our rover, some kind of communication that we might have, or even at the level of the at the moon, there are communication opportunities or communication standards that we can have. There is no GPS there, but let's move ahead. The key thing is whatever we design, this is all true, okay? Like this is kind of an external requirement saying, hey, be careful with the regulations that affect all of these. It's okay. Okay, here we go. Oh, stickers. Oh, we didn't change stickers, that's fine. Okay, so as we design things for the moon, these requirements, gravity, well, gravity, vacuum. Well, as you know, working on a vacuum, that means no atmosphere. Okay, no atmosphere is really important. Gravity, 1/6 of the Earth gravity on the moon. So everything in there is different. That's why the design of the rover is this type. Then lunar day and lunar night. What does that mean? How many hours of day? Where is it located? Now, how many hours of night we will be measuring? What type of radiation, galactic rays, X-rays, galactic rays, what kind of radiation are being exposed to? Okay, so that's how we're going to protect our rover, what kind of materials are we going to face. Solar radiation, that one is obviously unclear. That includes solar flares. Surface temperature, because of the overall cryogenic, definitely too cold to happen in there. Then all the micrometeorites that the moon has been subject to and continues to be subject to. The moon dust, obviously, and we've got already some examples: hermetically sealed, excavation and hoisting and stowage. And this would be a great introduction for us to see. We got to see the rover. And it's always nice when we cover the definition comes in. And over micrometeorites, moon dust, electrostatic environment. We cannot ground something on the moon, like what we have on Earth, because there is no grounding mechanism. So we need to find a way, as the temperature scope moves in, to understand if our electrical equipments work. Regolith. So this is the thing that I'm picking up. What are the characteristics and overall the geotechnical properties of the moon? Okay, where are we traversing? What's the inclination of things? What kind of materials are we going to find? So really, really important. More requirements that influence, I'm going to say, the subject of your operation. Okay, that's where they will land. So all space missions could these basic elements to some degree. Syntax for definitions. You need to buy the book. It's definitely an investment. But I would like to give you guys this today as you progress not only in being a Scrum Master, but also a space Scrum Master and learning more about space. Enjoy your day, night, wherever you are. Reach out for any comments. We have a standing. I'm going to say a standing tally. A standing tally is when you go to drink something, but we have a standing, all the stickers in here. As I find solutions, I'll bring them over here. And I would say enjoy your day. Again, spacecraft architecture final review in here. We got the rover design. It was very, very populated, very interesting in here. The book review, reviewed some of the context in space architecture. You've got one of my videos over here explaining how to do space mission design analysis using the SMOD. The authors of the SMOD are here. Okay, full credits to them. James R. Wirtz, Davey F. Everett, Jeffrey J. Puskell. They are probably not already in those companies, but they are definitely the authors of this very well-known research book. Joe Justice that brought the book, and yours truly that gave you some of the notions when you start designing for the moon, what to do for the moon or for the spacecraft, what to do. More realistically on the side as well. Some of the work of George Sanders in there, and in this case, our architecture of the rover with the physical design. Today we've looked into the functional design and that interaction. And we didn't do the maintenance yet. That's fine. But very, very important when, at least from my view, I had these things many times. Like, we didn't talk about the legal requirements that affect all of these, or what even internal requirements. And as you've seen, making a shift to Joe's book, as you've seen, it's many interesting requirements come in starting from inside. Like they had the pilots in there to fly the jet. In our case, we'll have a controller to operate the rover. That would be very, very helpful. So this gives requirements for us to be able to work with that. And that's it. I hope you enjoyed Solocast today. Next week, definitely chapter 5 on Joe Justice's book. And I'm going to not do space architecture. I'm going to do what I'll do is something that has been troubling my mind for a while. It's trade studies. So enjoy and subscribe to the YouTube channel or reach out to me. And I'm definitely always available.